Hi, this is Subham Kumar Agrawal and welcome to my YouTube channel, that is the DU Chemistry. So in this video what we are going to discuss, today we will complete the rotational partition function, and then in the next video we will start with the vibrational partition function. Alright, so what we left in the rotational partition function, we had covered for the linear rotors. We had covered the linear rotors and partition function for the linear rotors. I can show that where we had stopped in the last video lecture. We had stopped with this question. With this question I had stopped the question of the GATE 2007. Alright, and what the concept that we had read in the last, we had completed the expression for the rotational partition function by including this sigma value. Why we have add or included the sigma value? Because there are some conformations of the molecule which are indistinguishable, but we were assuming that the particles are distinguishable, and we had find out this expression which I had said this was yet incomplete. So we had gone to this sigma. That sigma is what? The conformations which are indistinguishable. So sigma value will cover those indistinguishable conformations. Alright. Okay, so we have done with this, and today we are going to discuss about the non-linear rotors. Alright, non-linear rotors. So for in non-linear rotors, the first one is the spherical rotor, because we had already done with that. There are three types of non-linear rotors: spherical, in which all the moment of inertia I value are equal for the A and B and C, and for the symmetric, the second one was the symmetric, and third one was asymmetric. Alright, so in the first one, that is the spherical rotors, we know that the B value, only the difference will occur in the B value, because I component is involved only in B value, and the rest of the partition function value is same. So theta t will be same, but the difference will occur only at the point of the I, because if I will change, these values will get different. But in this case, all the three values of I, of A and B and C are equal, so the B value is equal for the all three I, so nothing change will be seen. Alright, nothing change will be seen, and you will get the same partition function value. Alright, now for the symmetric, there I have already said that there will be the difference in the B value. B, that is the rotational constant, that is the energy which is involved in the energy expression of the rotational energy states. Alright, so this B value will have changed when we have a change in the I value. When we will have the change in the I value, then only we will get the change in the B value. Alright, so in this case, in symmetric, we know that the IA, the two are equal, and the third one is not equal to the previous two one. So we will get the two value for the B. Alright, we had the one value is this, where IA and IB are equal, and the other value is unequal, because IC is different from IA and IB, so we will get this whole value different. So here I had designated it by A. Here I had designated it by A by replacing the B with A, because it have a different value. Alright, so this is all about symmetric rotors. Now for the asymmetric rotors, we know that all the three values are different. For the I, all moment of inertia in A, B and C, or say X, Y, Z direction, are different. So we will have a three value of the B. So here we have designated B with A and this B and this, because IA, IB and IC both all three values will be different. Alright, all three values will be different, so we will get the different A, B and C. Here we are designated since we get the different values. Alright, now so now for asymmetric rotor, as we have different B values for each of the IA and IB and IC. So the condition what here we have, when the temperature is greater than theta R, means characteristic rotational temperature, we have the temperature greater than the characteristic rotational temperature, it means all the states are accessible. Alright, so we had calculated the QR expression for this, and here we had put A, B, C. In the expression there was B cube. So B into B into B, but all the B values are here different. So here we had replaced one B with A and one B with C. So here we had kept A, B, C. Alright, so this is the QR expression for the system asymmetric rotor. And you have to also remember this condition as well. We are talking about the temperature which is greater than the characteristic rotational temperature. Alright, now similarly for this is the expression in the centimeter inverse. When we will have these values in centimeter inverse, so we have to put the K as a KB dash, and KB dash has the value KB upon HC. Alright, so here we had used KB upon HC, so that all the values will be in centimeter inverse. Alright, now for symmetric rotors, two values will be same and one will be different. Alright, so here we had used AB square, so B and B, two values are same, and the third one is A, that means the third one is different. Alright, so QR means partition function for the rotational will be 1 upon sigma KBT, as this what is being shown to you. Alright, now for this spherical rotor, and we know for spherical rotor all the moment of inertia are equal, that means A, B, C value will be same, and we here only put B cube. So we'll get the partition function for the spherical rotor as well. Are you clear with this or not? Are you clear? The concepts are clear or not? I hope that concepts are clear to you. Alright, now what we have, there is a problem. What is the problem? When in the question will ask, then how you will know that whether we have to take the linear or non-linear in spherical, symmetric or asymmetric rotors. How you will identify that? In the question we will have to use the formula for the linear rotor or the non-linear rotor. Alright, so the answer of this question is that in the question you will be given the number of rotational constants. So depending upon the number of rotational constants given in the question, you will decide that whether you have to take for linear rotor or you have to take for the non-linear rotors. And if you will get the single rotational value, then you will have to choose either from the linear rotors or in the non-linear spherical rotors, because for both of the linear and spherical non-linear linear rotors and spherical non-linear rotors, in both the cases you will be given the single B value. Try to understand, you will be given the single B value in both of the cases, in linear rotor and non-linear spherical rotors. So in both of them, how will you differentiate that I have to find out actually for the linear or actually for the non-linear spherical rotors. So this will be judged, you will judge it by looking at the molecule. By looking at the molecule, that what type of molecule is given to you. If the molecule is linear, if the given molecule is linear, then you have to apply the formula for the linear molecule. You have to apply the formula for linear molecule. Alright, if the molecule given to you is linear, and if not linear, then obviously you have to apply for the spherical rotors. Spherical means non-linear spherical. So also you can identify it by their point groups. Either it has tetrahedral or octahedral or the icosahedral. These three will be the point groups. So if by these point groups you can also identify the molecule, and you can use, if the single B value is given, then you can use formula for the non-linear spherical rotors, as I already taught you. Alright. Okay. Now if in the question we will be given the two B values, if two B values is given in the question, then definitely we have to go for the symmetric non-linear rotor. Then we have to definitely go for the symmetric non-linear rotors, because we had already discussed that in the symmetric non-linear rotors the two values are same and the third one is different. So in the question you will be given the two values. Alright, you will be given to the two values. So in this way you can identify that which formula I have to go with that. Alright. Now if the three B values will be given to you, if the three B values will be given to you, then you will be automatically the thing will come in your mind that I have to use for formula for the asymmetric rotors. Alright, all the things are clear. I hope that all the things might be clear to you. Now I am moving onwards. Now I have a question. Try to coordinate with me, because it is a quite good question. Okay, so what is the question? Q with 0 point energy and Q without 0 point energy, will they different or will they same? The question is, will they be different or will they be same? So yeah, I know that you know the answer, because the answer is being shown up to you. Both value will be same. Q without 0 point energy as well as Q with 0 point energy, both will be same. Why? Because the 0 point energy is 0 in the rotational spectra. In the rotational of the molecule, the 0 point energy is 0. That is why we say Q with 0 point energy is equals to Q without 0 point energy. How the ground state energy is 0? How? Because E is equals to B J into J plus 1. So J is the rotational energy levels. So when you put J equals to 0 for the ground state, it means for the ground state you will get the E as 0. That means the energy of the ground state is 0. Alright. Okay. Now I have two more questions. So please coordinate with me. Alright. So the first one is, if temperature is equals to infinite or temperature tends to infinite. If temperature tends to infinite, what will be the rotational partition function? Don't look at the answer. Just try to answer with by yourself. Alright. So yeah, you can see in the screen that the answer is given to you, that the QR will be infinite, because all the infinite states are can be accessed. Try to understand. We had read the rotational characteristic temperature. Which is nothing but these energy, the temperature or the energy, these energy difference are the characteristic rotational temperature. Alright, because the temperature or the temperature needed to cross these energy states is the characteristic rotational temperature. Basically we can conclude this. Alright. So if the temperature is infinite, means all the states can be accessed. infinite states are possible. This is very clear, because all the states can be accessed. Any of the state can be possible if temperature tends to infinite. So at that point of time we can say that the partition function or the QR tends to or will be infinite. Alright, is this thing clear to you or not? Is this thing clear to you or not? I hear assuming that this thing is clear to you. Alright, now the second question, if temperature equals to 0, then QR means partition function for the rotational, for the linear rotor will be, QR linear will be. So in the screen you got the answer, that at temperature 0 only the ground state can be accessed. At the temperature t equals to 0 only ground state can be accessed, because this is the theta t. Alright, theta t or theta r, sorry, this is the actual temperature which you need from going from the ground to first excited state. So for this we need some temperature, but if temperature equals to 0, no transition from the ground to excited state will be takes place, and all the molecules are in the ground state. That is why I had said that at temperature equals to 0, Q1 will be Z0. Z0 means degeneracy of the ground states. So only ground state can be accessed. Is this thing clear to you or not? We can also find it by using the formula as given to you, that Gj equals to 2j plus 1, degeneracy of the jth state. So for the ground state we have to put j equals to 0. So G0 will be 1. That means only one state is possible in the ground state. That is also very amazing thing. Alright, yes, because only one ground state, degeneracy of the ground state will be 1. That means only one state will be possible at the ground state. So here we had said Q1 equals to G0 and G0 equals to 1. So Q1 will be 1. That means QR linear will be 1. This is the final answer. That the QR linear equals to 1. I here assuming that you people get clear with this all concepts, and I had already discussed all these things in the previous videos. So if you are watching this from this, so you will not be able to access all the concepts whatever I am taught. Alright, here I had taught. So first of all I request you to go with those previous lectures as well, so that you will get an idea that what here I am talking about. Alright, so guys, this is all for today, and in the next video we will be going to start vibrational partition function. So, and in vibrational partition function we will be going to have a lot of fun, we will enjoy a lot. So till the next video, see you, have a good day, bye bye.